Hello everyone, very nice to meet you. I'm honored to be present here today. My sincere appreciation goes to LGU Plus for giving us the invaluable chance to be a part in this PlugFest. I'm Ramon from InnoWireless. We have Accuver brand globally, so please allow me to use InnoWireless and Accuver in this presentation. Today's agenda includes the following topics: testbed setup, working group for IoT test result and details, and then I'll conclude with our strength. This page shows the logical architecture. You can see EasySO at the top left. EasySO is the product name of our solution for ORAN. It collects real-time traffic data from the interfaces of RU, TU, and CU, and performs detailed analysis of each interface and protocol. EasySO is orchestrated with XCAL-DM and the spectrum analyzer, which is named XCAT-IXA. As a result, we offer a comprehensive ORAN test solution portfolio that covers three main areas: Working Group 4 IoT, Working Group 5 IoT, and TIFG E2E test. In this PlugFest, our solution was used to validate frontal interoperability. This page shows testbed setup. It explains more specifically than logical architecture in the previous page. We configured the testbed with Nokia TU, CU, and application test server, and Korea third-party RU. The TU and RU are connected with 10G optical cable, and all frontal traffic were collected using TAP. The XCAT-IXA, a spectrum analyzer positioned on the right, is connected to the GPS antenna and can measure the RU time offset and frequency offset by analyzing the RU signal. EasySO is configured to work in conjunction with XCAL-DM. The role of DM is crucial as it manages the automated call of devices, collects and stores logs, and transmits the RRC message necessary for the IQ analyzer to perform channel decoding. This is system configuration description for a test environment. This table shows that the parameter setting value between RU and DU. EasySO must know these parameters in advance. If the settings are correct, EasySO is capable of calculating the correct KPI and channel decoding of IQ data. At this PlugFest, we conducted the Working Group 4 IoT test. The version of the standard referred to is version 10. Let's move on to the next. In this slide, I'm going to share the test result. As you know, Working Group 4 IoT has 23 test items. There are 8 cases in which the test environment is not configured, and 8 test cases are not defined in the standard yet, so only 7 items were tested. In the table, you can see all test cases passed, which have been planned to be done. This is the test report. After completing the test, EasySO provides a batch report automatically in the format defined by the ORAN Alliance. It shows the time the test was conducted, the number of test cases executed, and the test status, pass or fail. Let me show you 4 test items from now on. The first one is startup in hierarchical mode in M-plane. Frontal protocol analyzer is used to verify M-plane flow and message contents. At this PlugFest, RU and TU netconf was encrypted by secure shell, so M-plane message could not be confirmed through captured packets. During the test time, wireless parameter values are received from XCAL, and the netconf command is executed to RU directly to acquire parameter values. You can see the log on the left is the XCAL-DM data, including PCI, bandwidth, SCS, and MIB value, and the table on the right is the log of EasySO and the detailed report result. Since the value received from XCAL-DM and the value received from the RU were the same, so it was judged as pass. The following test item is a S-plane performance test in LLSC1 environment when two RUs are linked to one DU. Spectrum Analyzer XCAT-IXA was used to measure the radio interface of RU. The image on the left is a screen capture of XCAT-IXA, including time offset and frequency offset. AGSO periodically receives data from XCAT-IXA, so it calculates the relative time between two RUs. The standard value of category B is that time offset is within plus minus 2060 nanoseconds, and the frequency offset is plus minus 50 ppb. You can see maximum absolute time offset is about 53 nanoseconds, and the frequency offset is 0. So the test was passed. The third one is radio U-plane downlink data transfer. In this test scenario, we need to test whether UE can perform radio U-plane data transfers with the network through TU and RU from different vendors. In XCAL-DM, a predefined automatic call is executed to test downlink throughput, and then AGSO can get data from XCAL. The image on the left is the log when the downlink throughput test was conducted using 4 layers and 256 QAM. You can see that on the right, the measured throughput is about 1.171 gigabps and the target data rate is 1 gigabps. So it was passed. Also, you can see that on the right bottom, it is provide a report in graph. The last test item I'd like to show you is the delay management of a CU plane. Since AGSO cannot measure the time between RU and antenna, the latency of packets between RU and DU was measured. As you can see the picture on the left, 2 taps were installed between RU and DU. The test was conducted by changing the cable length between taps. When the distance between taps is 5 meters, the latency average was measured to be about 20 nanoseconds. And when the distance is 10 kilometers, it is about 46 microseconds. In AGSO, identical packets can be checked using a tool called Packet Viewer, and the detailed report provides a graph on the latency of packets. This is our strength. With AGSO, we can monitor and analyze real-time packets for frontal, middle, and backhaul interfaces. Also, our solution provides a complete lab-oriented test solution portfolio of the following 3 parts: XCAL-DM, AGSO protocol and IQ analyzer, IXA spectrum analyzer. XCAL oversees UE trace, protocol analyzer collects traffic and acts as process role, and IQ analyzer processes IQ data to decode radio channels and provide a resource block map. Spectrum analyzer measures the time and frequency offset of RU. With this portfolio, actually we cover TIFG end-to-end test and Working Group 5 IoT as well as Working Group 4 IoT so far. This is a video recording of a test for radio U-plane downlink data transfer among the CU plane test items introduced earlier. In the batching setting menu, you can enter OTIC info and vendor info to be printed in the test cases and batch report. You can insert the target data rate of downlink. In batch status, you can control test cases after setting idle and cool time. When the test is executed, XCAL is controlled to do that. It also records throughput values every second from XCAL and the printed data in the report. This automated testing offers significant advantages in terms of ease of use and time efficiency. In conclusion, all the mentioned functions are provided through useful and simplified GUI. Also, you can elevate your efficiency with our automatic report generation function. designed to streamline your workflow and deliver precise, comprehensive reports at the click of a button. That's all I prepared for a presentation. Wireless and Accuver would like to thank LG U+ and our test partners in this PlugFest for the outstanding collaboration once more again. Thank you for having me.